Topic 6-3, solving quadratic equations on the calculator. Okay, we did this in 6-2. You can also find an example of a technology lab on page 628 in chapter 9, section 5, that shows a little bit more about the calculator use. But if we're going to continue to put these in our calculators, solving quadratic equations become easy if we know how to put it in the calculator. Although we also need to remember back in chapter 4, unit 4, that how to factor a quadratic. So if you want to look back, you have to remember that once we find the solutions, which we'll look at this one in the calculator, it's always in its binomial form the opposite. When you say x plus 6, solving that, subtract 6 on both sides, you get a negative 6. Same thing with the 1. If it's a 1, a positive 1, then in its binomial form, it's inside the binomial with x minus 1. So it's always going to be the opposite once it's in its factored form. But to get a little bit better understanding of that, let's go ahead and I guess we'll use this one as an example. So put in x squared plus 5x minus 6, and then this is what's important here, because this one actually does factor completely, but sometimes it'll be a fraction. But if you make a habit of putting a 0 in for your y2, then you're actually going to be able to use this technique using an intersection, because the whole idea is that as we're looking for the solutions to a quadratic, you're looking for right here and here where it's crossing our x-axis. And if this solution is also finding just the intersection of this line and this line, that x-axis is y equals 0. So in our y2, if we make this the other one line of intersection, then we'll be able to get our point of intersection. So let's just, let me explain how that works. If I hit second calc, it's above the trace button, and go down to intersect, you're going to see the parabola drawn. You want to move the cursor along the x, or close to the x-axis. And it's very important that when we're moving this cursor, we use these arrows here and here. If you use the top arrow and the bottom arrow, you're likely to have the cursor move off of the parabola. So as long as it's close, then you're going to do step G, then hit enter, enter, enter. So what happens is it makes a guess, and it tells you that that one is, that intersection of that line is 1, 0. Again, you're walking over a value of x, and then you don't go anywhere for your y. So now we're going to go look for this one. So it appears that our y-axis on this one's about right there. This is your y, and this is your x. So now we're looking for this one. So when you hit second calc again, choose intersection. You want to move the cursor. It's going around and around. It'll come back up. And you want to get it close. As long as it's close to the x-axis, the cursor, I should put here close to the x-axis. Once it's close and you hit enter 3 times, it will give you the intersection. Now this one you could have actually also, because it's not a fraction, you can always go to the table first. In fact, I encourage my students to go to the table and look for, my table set's not set. It's at ask. I knew that because of the way it had a whole bunch of fractional numbers too. So if you hit, now we're back to just our zeros. You're looking for your zeros. Well, these just happen to be at positive 1 and then again at negative 6. You can actually find that the vertex is in between here too, just looking at the table. Somewhere between 2 and 3 on the x-axis, negative 2 and 3 on the x-axis, and between negative 12 would be my vertex point. But we'll get into that look also in a little bit. So compare the x-intercepts to the solution. What can you conclude? The x-intercepts of this solution, they're always at, I don't know why it says they're the same. Oh, well, the solutions to this one. Oh, I see. Okay. The solutions to this problem, and then putting it in a calculator, you'll notice that they're the same. We're still getting the x value to be a -6 and a +1. On testing, sometimes they'll show it with the two x's, but sometimes they'll actually put it in brackets. Well, they won't just put the solutions named just with numbers. They'll put it in a bracket and say -6, 1. You have to understand that these brackets make it so that it's the x values and not a coordinate plane. Coordinates are shown in parentheses. X values, where this is an x and that's an x, are shown with brackets. And sometimes answer choices are actually written like that. Okay. Graph the quadratic equation and find the x-intercepts, the solutions, the factors, the vertex, and the y values for the given x values. So there's going to be quite a few on your assignment pages that you're going to be asked to find all. Intercepts, solutions, factors, vertexes, and the axis of symmetry. Always remember that your axis of symmetry is just an x, whereas your vertex is the coordinate plane, x and y. If I were to plot where my vertex was, it would be this right here, vertex. So, I'm going to let you all just do these on your own, but go back to your y equals, put in this equation, and look for where it hits your x-axis. This is the x-axis. This is showing your y-axis over here. So you're looking for values of where the number walks across, stops at. This one looks like it's 3, 0, and this would be 5, 0. So those are our x-intercepts. But do practice this with the calculator and not just showing these points here, filling it in. So again, do all of these problems and check your answers with mine. The reason that this one you would write no solution is that when you do throw it in the calculator, you're going to see that it doesn't ever touch the x-axis. If this is my x-axis, it does not cross the x-axis, you would have an answer of no solution. So on some of the assignment pages you may have that happen. But again, put these in your calculator, use the calculator technique to discover where your solutions are. And remember, these are not coordinate points, so you could actually put them in a bracket if you wanted to. And then the last thing is just a reminder and kind of scaling back to what we learned last time. Using the axis of symmetry formula, find, using just algebraically instead of a calculator, find the axis of symmetry of this equation, plug it back in. Once you got the answer as -1, you're putting it back in for these x's and solving for your vertex point. So your vertex point would be this. Did it end up being -1? Huh, I forgot to put that. It's actually negative, and then a -5. Okay, and that concludes 6-3.